Hello students, now we are going to start Brain Teasers of chapter 2. Okay, so let's start. Question number 1a, take the correct option. First, the additive inverse of minus 3 upon 4 is, from this option we have to say. First of all, this is additive inverse. So if it is negative, the answer will be positive. So, and it is not reciprocal. We don't have to find reciprocal. Reciprocal comes under multiplicative inverse. Reciprocal means we write 4 upon 3, that is reciprocal. But this is what? Additive inverse. So additive inverse and multiplicative inverse, that is reciprocal, are different. So the additive inverse of minus 3 upon 4 is what? 3 upon 4. Not minus 3 upon 4, not minus 4 upon 3, not 4 upon 3 also. 4 upon 3, see, this is inverse. Okay, but additive inverse, only the negative will change to positive. Okay, so 3 upon 4 is the additive inverse. Okay, so we'll write 3 upon 4 is the additive inverse. Okay, next question. B. If x, y, z are rational numbers, then the property x plus y bracket then z plus z is equal to x plus bracket y plus z is known as which property from this? Commutative, associative, distributive or closure property. So here if we say in additions we have these two properties, commutative and associative. Distributive we have for multiplication. So but this property is what? So this property is associative property. Okay, they have grouped x plus y and then z, and again x is out, then y plus z grouping is there. So this property is known as associative property. Okay, now next, 7 upon 12 divided by minus 7 upon 12 is means we have to find the answer from these options. So what it is? See, 7 upon 12. Now division will become what? Multiplication. And minus 7 upon 12 will reciprocate. When division becomes multiplication, the number, rational number on the right hand side becomes reciprocal. So what we will get? 12 upon minus 7. Okay, so 12 and 12 get cancelled, 7 and 7. What we get? 1 ones are 1 upon 1 ones are 1 and down minus. So minus 1 we get. So where it is? This third one. So what is the answer? Minus 1. Okay. Next, the identity element for subtraction of rational number is. So what is it? It does not exist. What is the answer? Does not exist. See, identity elimination for addition is what? 1. Multiplication is also 1. But for subtraction it does not exist. Next, the multiplicative inverse of 6 1 upon 3. What is multiplicative inverse? Reciprocal. We reciprocate that. So first, this is what mixed fraction, we have to bring it in proper fraction. So 6 3s are multiply. We multiply this and then add with the numerator. So 6 3s are is 18. 18 plus 1 is what? 19. 19 and then denominator as it is we write. So 6 3s are 18. 18 plus 1 19. So we get 19 upon 3. And for this we have to write the multiplicative inverse, which is 3 upon 19. 3 upon 19. So where is 3 upon 19? See, third one. So this is the answer. Got it? Now next question. B. Answer the following questions. First, write all rational numbers whose absolute value is 5 upon 9. 5 upon 9 is the answer. So what are the options? One is what? 5 minus 5 upon 9 if we write. So minus 5 upon 9, we will get 5 upon 9. Again 5 upon 9 also in the absolute value we get 5 upon 9. Right? So which are the two options? Minus 5 upon 9 and 5 upon 9. Okay. So what are the answers? Minus 5 upon 9 and 5 upon 9. Okay. Next, find the reciprocal of 4 upon 5 multiplied by 3 upon minus 8. Now we have to find the reciprocal. So first we have to solve this, because reciprocal of this sum we have to find. Right? So we have to solve this. The answer we get, that we have to reciprocate. Okay. So let's see. So we have wrote the question. So let's start. So it is 4 upon 3 multiplied by 3 upon 8. 3 upon minus 8. There is multiplication in between. So we can reduce the number and then we multiply. So here 4 upon 5 we cannot reduce, 3 upon 8 we cannot reduce. Here see 4 and 8 we can reduce. So keeping it's like 4 ones are 4, 4 twos are 8. 3 and 5 we cannot reduce. So finally what we get? 1 into 3 is 3, 2, 5 twos are is 10 plus minus 10. So what we got, 3 upon minus 10 is the answer. Now reciprocal of this. So is what we got the answer for this 3 upon minus 10. So the reciprocal of this will be minus 10 upon 3. Okay. So this is the answer, minus 10 upon 3. So next question we will see. What should be added to minus 5 upon 11 to get 26 upon 33. So what should be added, means what number, a number added to this. This is one number and one more number, means we will take it as x. They both will be added, so we get what, 26 upon 33. So we have to find that x. Okay. So how we will start now? So first we will write one number is what? One number we have got, that is 5 upon 11. Let the other number be x. Be x. Okay. So according to the given number, what they have told, what should be added to minus 5 upon 11. So minus 5 upon 11 and x we will add. So minus 5 upon 11 plus x, what we get? See, they have mentioned to get. So what we get? 26 upon 33. Okay, now here we have to find this x. So what is the sign between this? Plus. Okay, so this goes here, it will become minus. So x will remain as it is, and 26 upon 33 it will remain as it is. This, see here, full minus 5 upon 11, the sign is here plus. Okay, so this goes here, it will become minus, and minus 5 upon 11 will remain as it is. Got it? X remain as it is, this as it is, only this goes here, so it will become minus 5 upon 11. Now we have to subtract both rational numbers. So first we have to equalize the denominator. So if we see, we have 33 and 11. So 11 into 3 will get 33. We'll get 33 over here. How? When we multiply by 3. 11 3s are 33. So we'll get same denominators. So down we have multiplied by 3. So up also will multiply by 3. So what I get? 26 upon 33 minus 15. 5 3s are 15 upon 33. Okay. Now what I got? 33 and 33 common. I will write. Okay. I won't subtract this. I will write it as common. And up I got 26, then this minus, and again minus 15. Okay. We will continue on the next page. So now what we got? 26 plus 15 upon 33. Here what we had? 26 minus 15. So minus will become what? Plus. 26 plus 15. So same I have done, 26 plus 15 upon 33. So then when we add, what we get? 41. 6 plus 5, 11, 41 upon 33. Further we cannot reduce this. So what we get? 41 upon 33 as the value of x. Sorry, here I will write x is equal to. Okay. So therefore the other number, okay, the other number is 41 upon 33. Okay. Now next question. Subtract 6 2 upon 3 from the sum of minus 3 upon 7 and 2. What is this meaning? We have to subtract this number from this number. From what is this number? Sum of this. So first sum of this and this. So first we have to add both, minus 3 upon 7 and 2. So whatever number we get over here, we are going to subtract it by this number. Got it? We have to divide the sentence. Subtract this number from what? From the sum of this. So first we will add this. Okay, minus 3 upon 7 and 2. Okay, so minus 3 upon 7 plus 2 we are going to add. So here also there is no denominators. So we require what? For addition what we require? The same denominators. Denominator should be same. So I will multiply. Here nothing is there, matlab I will calculate it as 1. 2 upon 1. So I will multiply this 7 over here. So I will get 7 here. So down I multiplied. So up also I will multiply by 7. So what I got? Minus 3 upon 7 plus 2 sevens are 14 upon 7. Got it? Now I have same denominators. I will write it as common. And up I will add now. Minus 3 as it is I wrote, plus, and this 14. So minus plus, different signs, minus plus minus. 14 minus 3 is what? 11. What is the sign of 14? Plus. So it will be plus 11 upon 7. So this is the number I got. This is the number I got for this, minus 3. Now here I got 11 upon 7. Now this number I will subtract with this number. Got it? So what they have mentioned, subtract 6 2 upon 3 from 11 upon 7. From 11 upon 7. Now we have to subtract. So from when comes, so this side number will come here, 11 upon 7. Okay, subtract this from this. From is there, so we don't do like this minus this. No, this will come here, then subtraction, then 6 2 upon 3. Okay, now first we have to convert this mixed fraction into proper fraction. Okay, so 11 upon 7 as it is I wrote, minus 6 into 3, we multiply this and then we will add with this. 6 3s are 18, 18 plus 2, 20, 20 upon 3 I got. Right, now we have to subtract these two numbers. So for subtraction we require same denominators. Both are prime numbers, not doesn't go in each table. So I will multiply 3 here. Okay, so up also I have to multiply. I will multiply 7 here. So up also I have to multiply. Okay, so 11 3 is 33 and 7 3 is 21. So 33 upon 21, then minus 20 into 7 is 140 and 3 sevens are 21. So 20 into 7 is 140 upon 21. Now I have same denominator. So I will write it as common. Okay, write it as common. So in the numerator I got 33, then minus 140. Now I will subtract. Okay, so 33 minus 10 3 7 0, 107 I got. 140 minus 33 I got 107. Who is bigger? 140. Sign of 140 is minus. So minus 107 upon 21. Okay, further we cannot reduce this. So this is the answer. Next question. Find the value of 1 plus 1 upon 1 plus 1 upon 6. So we have to add this and this total number. Okay, 1 is as it is. So here see 1, then divide by, again we have to do this addition. We have to find the denominator and then add this. Okay, okay, let's solve. So 1 as it is I wrote, plus this one as it is I wrote. Now here what is that? This is division. So instead of writing this I will put the sign of division. Instead of this I wrote the sign of division and I will write this whole here. See, 1 divided by 1 plus 1 upon 6. This is also 1 divided by 1 plus 1 upon 6. Now first we will solve this. Okay, so remaining I will write as it is, 1 plus 1. Division also I will write as it is because we are solving this one first. So what is there? 1 plus 1 upon 6 plus is there. So again when we have to add this, we have to equalize the denominators as there is addition in between. So what I will do here, nothing is there in the denominator, I will multiply 6 over here. Then we will get same denominators. See how? So this is division. Okay, 1 upon 1 into 6. So multiply by 6 up also. This plus comes, then 1 upon 6. I will keep it as it is because already I have 6. Only here I required, so I multiplied by 6. Again remaining we will write as it is. So 6 ones are 6 upon 6 plus 1 upon 6. Okay. Now I have same denominators. So 1 plus 1 divided by 6 and 6 I will write it as common. In up what I have got 6 plus 1, that is 7 upon 6. Okay. Now further we will do the, see this is division. When division is there, what we write the sign? 1 plus 1 division will become multiplication. This I wrote as it is, division will become multiplication. So this number will reciprocate. So it will become 6 upon 7. Okay. Further 1 I wrote as it is plus. Now see here, between 1 and 6 upon 7 there is multiplication. So we are going to add the multiply this, sorry. So 1 into 6 is 6 upon 7. Got it? I multiplied this. So I got 6 upon 7. Further, now there is addition in between these numbers. So again I have to equalize the denominators. Right? So here what I will do, there is nothing, so I will consider it as 1 and I will multiply 7 over here. So I will do it here only, 1 into 7. So up also I will multiply by 7. So I am doing here only. So what I got, 1 into 7, 7 upon 7, right, plus 6 upon 7. Now I have same denominators, so I will write it as common 7. In up what I got, 7 plus 6, that is 13 upon 7. 13 upon 7. So this is the answer. Okay, so we have completed question number 1B. Students, now we are going to start question number 2 of Brain Teasers, chapter 2. State whether the following statements are true or false. If false, justify your answer with an example. Okay. First question, if absolute value of x is equal to 0, means in the absolute value whatever number is there, we get the absolute value answer as 0, then x has no reciprocal, right? When we will get 0, see this is absolute value of 0 will be only 0. Absolute value of 1 will never be 0, right? So what is x over here? So this won't be there, okay? So answer is what? 0. Absolute value of 0 is only 0. So what is x over here? 0. X is what? This 0. Can we reciprocate 0? No. Okay. So what is the x has no reciprocal. So yes, x has no reciprocal. So answer is true. Okay. Next, if x is smaller than y, then absolute value of x is smaller than absolute value of y. So let's see, we will solve this. Okay. So if I take x and y, if I take x as minus 3 is smaller than minus 2. So x what I took? Minus 3 and y minus 2. So this is, but obvious minus 3 is smaller than minus 2. But when we put this in absolute value, so absolute value of x, that is absolute value of minus 3 is what? 3. And absolute value of y, that is here it is minus 2, it is what? 2. Now if we compare 3 and 2, this is greater. Okay, but they have given what sign this? X, absolute value of x is greater than absolute value of y? No. Here it changes. Here it was minus 3 was smaller. But when we put it in absolute value, the answer we get that is greater. Okay. So answer is false. Okay. And you can give this example. Write it as let x is equal to minus 3 and y is equal to minus 2. So minus 3 is smaller than minus 2. So absolute value of minus 3 is what? 3. And absolute value of minus 2 is 2. Here 3 is greater than 2. Okay, so false. What is the answer? False. Okay. Now next question. If x is smaller than y, x is smaller than y, then x raised to minus 1. What is this x raised to minus 1? We reciprocate. Okay, so the reciprocal of x, this is what, x minus 1 reciprocal. This x is there, its reciprocal is this, is also less than y reciprocal. So x is less than y. So the reciprocal is also x reciprocal is less than y reciprocal. We have to see this true or false. Okay, this. Okay, so how we can take next one example. X is less than y. So then reciprocal of x is also less than reciprocal of y. So if I take what, x as 2 and y as 3 I took. Okay, so here it matches that 2 is smaller than 3, right? X is smaller than y, 2 is smaller than 3. Now I will reciprocate this. See, x raised to minus 1 is what? So reciprocal of 2 is what? 1 upon 2. And reciprocal of y is what? Here 1 upon 3. So here who is bigger? This one. 1 upon 2 is bigger. Okay, 1 upon 3 is not bigger. So, and what they have given here? Smaller than x. Reciprocal of x is smaller than y. So again here what is the answer? False. Okay. So we'll write false. Now next question. The negative of a negative rational number is a positive rational number. True? How? See, the negative of a negative, what is a negative rational number? Like if minus 4 upon 3 is a negative rational number. So the negative of a negative, so this negative. So it becomes minus minus plus. So plus 4 upon 3 it becomes. So it becomes what? A positive rational number. So here it is true. Okay. Now we move to the next question. Next, fifth one. Product of two rational numbers can never be an integer. What are integers? Like 0, positive numbers, negative numbers are integers. Okay, rational numbers. So we can take example like two rational numbers. So if I take 2 upon 3 multiply by 3 upon 2. Two rational numbers, I have one rational number, one rational number, and product of them, so I will multiply. What I get? 2 and 2 get cancelled, 3 and 3 get cancelled. Finally, what I get? 1. So 1 is what? 1 is also an integer. And they told us it can never be an integer. The product of two rational number can never be an integer. No. We got the answer as integer only. So what is the answer over here? False. You can give this as example. No, for justification, not example, justification. Next, product of two integers is never a fraction. True. Why true? Two integers are never in fraction. Integers are like 0, positive numbers 1, 2, 3, 4, 5, 6, 7, and negative numbers like minus 1, minus 2, minus 3. So if I take minus 3 multiply by minus 2, what I will get? Plus 6. 3 2s are 6. If I take 5 into 4, 5 4s is 20. I will get 20 only. If I multiply 0 by 10, what I will get? 0. So I will never get the answers in fractions. I will get it in proper numbers only, integers only. Okay. So the product of two integers is never a fraction. True. Okay. Next question. If x and y are two rational numbers such that x is greater than y, then x minus y is always a positive rational number, right? X and 2 are two rational numbers and x is greater than y. Okay, so if I take like 3 upon 2, I took a positive rational, two rational numbers they have told. So x is greater than y. So I took 3 upon 2. Okay, and then what they told? X minus y. So x minus y I will take minus 3 upon 2 or any other number we can take. Okay, so if I want, I can take 4 upon 5. Yeah, 5 upon minus 5 upon 2. Okay, so y I took, see, this is positive because x is greater than y. So positive and this is negative. So x is greater than y and there is subtraction x minus y. So to prove that this, the answer of this will come as positive rational number. So is equal to, now see this 2 common I took and 3 minus 3 upon 2. 3 upon 2 is 2. 2 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 upon 2 is 2. minus 5. What I get? 3 minus minus plus 5 upon 2. So I get 8 upon 2. Right? See, 8 upon 2 is a positive rational number. So, got it? So the answer is true. So if x is greater than 2 and when we subtract that answer, we will always get positive rational number. So we have completed question number 2.